We want to sketch the following rational functions. Now the first thing I'd note here is that this is an improper fraction. The degree of the numerator is the same as that of the denominator. So let's actually do the division. So we've got x plus 3 in here. So x to get x gives us 1. So that's x take away 3. And then we'll subtract, and that gives me 6. So we can also write this as 1 plus 6 over x minus 3. That tells me that 1 is a horizontal asymptote. Think about x becoming large. When x is large and positive, the bottom is going to be a huge positive number. So we're going to have 6 divided by something huge and positive. It's going to be very, very small, close to 0 and positive. So that tells me that y tends to 1 from above because the expression will be positive when x tends to positive infinity. But if x is large and negative, then we'll have 6 divided by a large negative. That's going to be close to 0 from below. So y is going to tend to 1 from below when x tends to negative infinity. From here we can see that we have a vertical asymptote when x is equal to 3. We could look for turning points. So u is x plus 3, v is x minus 3. So du dx would be 1, dv dx would be 1, and so dy dx would be x minus 3 take away x plus 3 all over x minus 3 all squared, which is negative 6 over x minus 3 all squared. And since this is a constant on top, this can never be 0. So we can say there's no turning points. We could do a region analysis. So we have two things making up our function. We have x plus 3 and we have x minus 3. And then we can see what happens to y. So this one changes sign at negative 3. So we'll look at x is less than negative 3. This one changes sign at 3. So we'll go from negative 3 through to 3. And then we'll go for x more than 3. We'll see what happens. So less than negative 3, both of these would be negative. And so overall we get a positive. Between negative 3 and 3, this one becomes positive, negative, so negative, and then here they're both positive, so overall positive. So let's have a go at the actual sketch. So x-axis along here, y-axis up here. We have a vertical asymptote when x is 3, so let's put that on here. So this one is x equals 3. One thing we didn't do was the intercepts. So y equals 0 means that x is equal to negative 3. We need to make the top equal to 0. So we can see that there's going to be an x-intercept at negative 3. What about x being equal to 0? When x is 0, y would be 3 divided by negative 3, so y would be equal to negative 1. So let's put negative 1 here. So that's a y-intercept just there. And let's see what happens now. We know there's a horizontal asymptote, and that horizontal asymptote we found over here was y is 1. So, let's get the right colour pen, and then we know from -3 backwards, positive, so the curve's going to be above the axis, and from here we know it tends to 1 from below when x tends to -infinity, so it must go out along here like so. And the only thing it can really do is come down through this point and this point, and then carry on and go off down the vertical asymptote here. So that fits with the table, with it being positive along here and then below the axis down here. Then to the right of the asymptote it's going to be positive, and the only thing it can really do is go up here, because when we're close to 3 the denominator is close to 0, and then from here we know it tends to 1 from above as x tends to infinity, so it's going to go along the asymptote like that. So this is y is x plus 3 over x minus 3. Here's an accurate plot of the same function. We can see the horizontal asymptote here, y equals 1. We can see the vertical asymptote, x is 3. We can see the features that we have here, and the intercepts here and here, tending to 1 from above, tending to 1 from below